Okay, so today we'll be holding the, can you guys hear me first of all? Okay, perfect. So today we will be holding the PCB workshop. We will use one of the software used to design PCBs, which will be Autodesk EAGLE. EAGLE before was a software on its own, designed by another company called Cadence, but then Autodesk bought it because basically what Autodesk does is that it has software that are basically CAD software for different purposes. And Autodesk EAGLE is basically just the CAD that we use for PCB design. And in this workshop, rather than we're not going to be talking about how to do the circuitry because that's a whole profession, but we will just be discussing how to implement, for example, a design or already designed circuit, or that we had designed circuit, implement it to a board, and then do the whole process from a schematic, go to a board layout, and then generate Gerber files or the CAM files that are used to later to produce them. So basically, the summary of the workshop today, first of all, we're going to discuss what PCBs are, what are some different PCB design software that we can use besides EAGLE, and what might be some pros and cons of them. Then we're going to start heads-on with a schematic of a board. We're going to do a Blinko board, which is basically a LED flashing board, which is basically the basic PCB that everyone starts with. And then after that, we're going to draw the board layout. We're going to generate the Gerber files, and probably we're just going to see how can we print this, where can we print this, how to get a quota somewhere. And then we're going to probably play it by ear if we have time or not. Now it's 11:07. If we have time in the end, I would like to also mention how to create your own components. Most likely the components will be given. You can find them in libraries, in Git, and whatever. For example, Adafruit for Arduinos. But sometimes things happen and you cannot find the schematic, and you can just create your own one, basically. So what are PCBs? So my PCB is basically a printed circuit board. And my first PCB was this one here on the right. And basically it looks like it's a useless thing, but it's basically this very tiny bit here. This is the whole purpose of my printed circuit board. It is basically an interlaced microelectrode array where these electrodes are of the micron scale. So these are thinner than hair, basically. And they're a prototype, and they were used in a research to study the effect of the electrophoresis. I'm going to share this presentation later with you guys. And there's a YouTube video that if you'd like to watch how PCBs are manufactured, it's a pretty awesome video. So basically, long story short, PCBs are nothing but a copper sheet in the beginning. Then a machine takes these holes that you see here and drills them in that copper sheet. And then you take a film and then you place it over, you place it over that copper sheet. And after that, what happens is that that film has the printed circuit board design printed on it. And when you put UV light on it, when you put the UV light on it, the film will harden in these parts, in the holes where you see the copper. But it's not gonna harden in any of the green stuff. And what happens when you put the film and the copper in an alkaline solution afterwards, the film will protect the copper, but it will not, the copper that was not hardened with the UV, which will be the green part, will end up just looking like this and will not contain any copper. And all that will be remaining will be the traces and the pads where you can install your component, basically. Now, what are some different PCB designs that we have out there? Probably one of the oldest ones is Altium, or now called Protel, actually. 1980s. It's considered to be the best. Texas Instruments uses this. Linear Technology uses this. It's a very nice software. Then we have PADS, which is Power PCB. Then we have ORCAD. ORCAD is built by the same company as Protel. It's just ORCAD is a bit more tedious to work with and has less, because this is the main one. They tend to put more concentration on updates and everything and keeping up Altium. And then we have Allegro. Allegro is supposed to be the standard industrial design. So basically, whenever maybe I don't know, the clock that we have on the wall, it just has a simple chip or a simple PCB on the back, and that's how basically in the industry we just use Allegro. It has the DRCs. DRCs are the regulations and everything to do this. And then we have EAGLE, which is easily applicable graphical layout editor. It's a very user-friendly PCB design software. That's why we will be using it today. It's depending on what you want to do. In the beginning, the learning curve is all right. And then if you want to go into deeper stuff, there's a lot of potential in this software. And then it becomes a very steep learning curve. And then you can even use TinyCAD, which is free. But Autodesk EAGLE is free for students. So if you go, excuse me for that. So if you go to the Autodesk website and you register with your Drexel email, you can easily download it. And even if you can download it for free, it should cost like something like $14 a month, something like that. Now, this is a schematic that we will use for today. This is the Blinko board, and we have these two LEDs here. And these two LEDs, they flash once one, once the other. And then we're gonna take this, because we designed them on a breadboard, and now we're gonna take them, the prototype, and put it in a schematic. After that, we will take it from a schematic and we will end up with maybe a board layout like this. And then let's see how it goes. And if we have time in the end, we're gonna do the board. We're gonna do the creation of a new component. Now let me close everything down from EAGLE, and we're gonna start a new project. Now this is the, do you guys see this? Have I shared it correctly?
Yeah, I can see it.
Okay, perfect. So here, this is the EAGLE. I don't have the newest version, actually. I have the 9.5. It's been a long time I haven't used this. And basically here on the side, we have the main. This is the online stuff, what you're going to see, maybe tutorials, see what's new, forums. They have, EAGLE has very good support. Like any time of the day, you can ask questions and they most likely will respond to you. But here in the side, we have this drop menu here. And now we have libraries. Now, what are libraries? Libraries are basically folders which contain components, that the components are already built in. And when you want to drag, for example, a capacitor, you drag it from the RCL library, and you grab one from there and you put it into your schematic. Now, these are the libraries that are yours, that you created in the first one. In the second one, you can see the username. These are libraries that basically all the libraries that you manage, considering the one that EAGLE offers. Right here it says EAGLE PCB, so even the ones that EAGLE offers, even the one that I actually have made it so it doesn't show right now because it's a very long list. And here at the next one we have design blocks. Design blocks, these are your own design blocks, and these are examples that are already from EAGLE. For example, you have voltage regulators, you have, here I have Adafruit that is for Arduino. It's very helpful to have these things. You have SparkFun. there's a lot of cool stuff here that you don't have to draw every single time a voltage regulator when it's like it's the same in every circuit. Not really, but kind of. And sometimes when you design a circuit, and for example, you make your own voltage regulator and you like it and it works perfectly with the components that you have, you can create your own design block, and we're going to show it later how to do that and how to save it. And you go here and you can use the design block every single time you want to make a new schematic. Now, these are the design rules. So when you design a PCB, you can go crazy. You can go full manic and make cool stuff. But if you want to print it, then somebody's going to be like, this is not printable because it doesn't follow design rules. You're going to have trouble when you generate the Gerber files. And so basically, unless you have your own printer, it will be pretty much impossible to do it. Now, these are called user language programs. I do not have much experience with this, to be honest, but so I'm not going to talk about it. These are scripts. So scripts basically are ways for you to write in C language how to like control the board depending on the components that you have. So it's a very helpful tool. Now, these are the cam jobs. The cam jobs basically are after we finish the whole project and we process it, the cam job is the product that we have that we send to a manufacturing company to produce it for us, basically. And that's what's called the cam job. Now, this is the other one is spice models. Spice models right now, this is a very helpful tool that EAGLE has. So basically, EAGLE right now has added from I think version 8.5 has added an option to simulate your circuits. And these are the spice models. And we're going to go, when we design a schematic, I'm going to go and explain a bit more what these are. Basically, it's just a simulation technique. And projects, this is what we do here. Like example project, it always gives you something that's like you can see. And then here you have your own projects. Like here I have a micro electrode array, a coplanar electrode, and I tried yesterday to make a blinky board for this. So, and by dropping down, you can see this is how a cam job looks like. This is a schematic, and this is a board. And it's a description here. So now, if you see here, you have a green point. Wherever the green point is, it means that that project is active. So whatever you do, make sure to, so for example, if I press like save or something here, or delete, you're gonna delete this instead of that. So be careful, because that's happened to me before. Be careful where you like check where you are working, basically. So now to create a new project, we go under here and we say new project. Okay, sure. And we're gonna call it IEEE, or let's just call it PCB underscore workshop. Perfect. Now, under the project, we're gonna create a new schematic. Now, this is the, excuse me, this is the user interface that we have in the beginning. If you see this small circle, this small cross here, this small cross here is the 0, origin. And so let's dive in. So first of all, I want to give some advice. Never use EAGLE with touchpad. It's, if you do it, good job. You have a strong will. I would personally not do it. It's very difficult. So like every CAD software, just try to use a mouse, because you're gonna kill yourself if you don't. And then basically, let's go over the menus, what everything means. So up here, this is for you for sheets. We're gonna see what those are. These are, we're gonna use only these parts for today. Zoom, these are zoom to fit, they help. This is the stop. So an example, when you're like, want to delete something and you have finished, you basically just want to stop doing that. Now, this are called the layers. So a PCB is formed by different layers. As I said, we have a copper sheet and we have this film, and then we etch it, and like sometimes in processors, or I don't know, many different application, we don't have PCBs as simple as just with 2 layers at bottom and the top one. Like today we have PCBs that also have like 64 layers, and you have to keep track of them. And they're here basically, and you can choose which one to see by using this eye here. You can click here. Now, this is, if you're going to learn something from this workshop, this is probably the most important thing. So this is the grid. So never, at least in schematic, never change this. So you're going to keep it either 0.1 inch, or if you like the metric, you're going to keep it 2.54. And why do I say that? I say that because all EAGLE libraries are designed using even the line command, even the net command, rat's nest, everything in EAGLE that is offered by EAGLE, unless you do something or modification yourself, it is based on a 0.1 inch scale. And for example, when you want to connect 2 wires, it's not going to connect if you have a different one, and it's going to be so tedious for you to do things. So just make your life easier and keep it 0.1 inch, because if you change it and if you think you made the connection and you didn't, and you send it to the company with the quote, you pay the money, and they're going to be like, well, I'm sorry, this doesn't work. So that's a waste for you, and usually there's no refund back because they're not the most expensive thing to buy. Here we have simulation tools that we're going to use the spice models, and this is a selection filter. This helps a lot. Now I'm gonna go on and turn on the grid, so it makes your life a bit easier to look where things are. And now we're gonna start adding parts, what we need for our circuit. So let's start. So here on the right, here on the left, I'm sorry, you have all these commands. Here you have adding parts. This is moving, mirroring, and rotating. Here you have deleting, changing, copy paste. Here you have adding parts, adding design blocks, adding modules. This is adding nets and junctions, all those sort of cool stuff. Name, value, reposition attributes, replace. We're going to understand what these things are as we go over. So now if we go and add the part, if we click it, we're going to see that all these things are basically our libraries here. And this means, this sign here means is that it was offered through EAGLE itself. Right, if you see here, it says EAGLE PCB, EAGLE PCB. And this one, if you see Adafruit, this is something that I downloaded myself from Git. And this sort of tells you to like see what library might be safer, because these libraries like get updated continuously and are looked upon, and they're usually safer, and you have most of the components here basically. So now we're going to start with a frame. So we need a frame, so let's go to the frame library. It's here, and I like to use basically this frame A. Okay, you can open this description here. So it's going to be 8.5 by 11 inch. It has a lot of space for a PCB. So we go and place it. I usually like to put my frame at this line here, because just keep my reference system as 0, 0. Now to zoom out basically with the wheel on your mouse. Also, for example, if you zoom out of here, you go that way. So it's like you need to play around with this so you get the hang of it. It's not that difficult. Now there are 2 ways to go back and add another component right now. You can either hit the escape button and go back to the add command, which is right here, and we don't need the frames anymore. So we're gonna add right now the main component of our circuit, which is gonna be a 555 timer. So if I search for a 555 timer, nothing pops up. It says sorry, no match. So basically, how Eagle searches stuff is that it says take these three and look for words that only look like this. And that's tedious. It's not that helpful sometimes. So it doesn't even look like does anything start with this or is anything in the middle with this. So we make use of the so-called wildcards. So the first wildcard is adding the star in front of it or after it, and that means that it has as many characters in front. You don't care, it may have a full name. And if you add a question mark, you're saying that I'm requiring a component with whatever stuff before 555 and just one letter behind or one character behind. So if we go and search, we're gonna see here that under linear we have a timer. We also have under Adafruit. It's a very common component basically. So if we go here, we have all sorts of components basically. And now, if you look here in the right side, you have something called popularity. Popularity is so basically when I design PCB and I work in an online environment, or I upload it somewhere in Git, or I upload it somewhere in the internet, what Eagle does is it has an algorithm that checks what components are used the most. And this sort of gives you an assurance to see that like what components people think that are the best, or like what components are easier to find, because you may have components, for example, like this, but maybe no one uses it because it's not produced anymore, but the schematic is still there because it was probably used before. Now today we're going to use the NE555N. And now if you see here, actually, I don't know if it's big enough. Okay, now it's perfect. So if you see here, this is how it's gonna look on a schematic layout, and this is how it's supposed to look on the board layout. And this is how it looks in 3D. But I'm going to explain to you very shortly why it has a 3D version. Now, these green circles here, these mean that it is a through hole. So this is going to take so basically when it's going to be produced, there's going to be 8 holes in the printed circuit board that are going to be coppered, and basically that they transmit electricity. But you can also have something like this. As you can see, this is called surface mount SMD, so a surface mounting pad, basically. So if you see, these ones are mounted differently. These are not through hole anymore. So basically, we just have pads. Some people choose to use this because they'd rather not have holes in their PCBs. If you want to be advanced, sometimes it has thermal. Sometimes people choose for thermal issues, choose different stuff. Today we're going to go with through hole pad. Let's zoom in. We're just going to add this in the middle. I want this to be rotated, and I want to mirror this. I want the value on top, and I want it to be mirrored. Now you can rotate by right-clicking, and you can mirror by clicking on your mouse wheel. Now we're going to keep it that way. And now to add the component in the schematic, you just left click basically. Now we're going to need to add the other components. So we press the escape button again, and we need to add our capacity, our resistors. So search for RCL, it's not going to pop out. So just find the library, RCL, it's here. So RCL, resistors, capacitors, and inductors. It's one of the most used libraries in EAGLE. And if you look here, it says CEU, CUS. Basically, it's just probably it's the same components, just with Europe symbols and with US symbols. They're the same thing, just the notation in the schematic looks a bit different. The same goes for inductors and the same goes for resistors. So let's go at the American symbol R, and let's find out the capacitor RUS, which is all of them basically. R0 R063. Yeah, this is a very, as we see, a very popular popular resistor. So let's just grab that and plug that in here. So I'm gonna rotate it once, and I'm gonna put, let me get my schematic in front of me. So we're gonna put one here, and maybe one down here, and one here, and one here. Don't worry about making this all too pretty in the beginning, because this doesn't matter all that much. It's, of course, it's better to be pretty because you understand it better, it's more clear to watch, but don't sweat too much about it. Now we're done with resistors. Now we hit the escape button again, and at the same library we're gonna look for capacitors basically. So capacitors US, and now we're gonna find the capacitor, probably which one. Oh. Maybe this one, USA 120. What is it? This one. So now we're gonna rotate it, and we're gonna use one here, and we're gonna use one over here.
I'm sorry, I missed which capacitor you chose.
Yes, so it is the capacitor, this one, C1206. And you find it under the RCL CUS.
Awesome, thanks.
No problem. Now we added this one here. Now what we do, we hit the escape button again because we need to add the other components, and now we need to add the LED lights. So for the LED lights, how we're going to do it is that we're going to do, there's a lot here. So we're going to look around what might help us. So look at the L, and we see LED here. It says LED. The EAGLE libraries are very good because they give you a good enough description to see what are inside libraries. Now on the LED library, we go here at the other one, sub library, and we get a very commonly used one, LED 5mm. Press OK, and then keep it this way. No need to rotate this one, and add this one here, and add this one here. Now basically this is all our components that we need in a circuit, but we need to add one last thing, and the one last thing is a power source, because we're going to use a DC power source. So let's hit escape button again, and we're going to look for batteries. Let's close this. BP battery. Okay, perfect. And for battery, we're just going to use a 9-volt battery clip, a very simple one. We can see here basically in the schematic, and now we're going to put it in this side. So basically what I want to do here, I rotate it, and if you notice, the positive is on the bottom and the negative is on the top. Usually you don't want to keep it like this. It's there's nothing wrong with it, but just like some sort of notation that people like to do is that they like to keep the positive on the top and keep the ground on the bottom. It's just more of a convention really, rather than something required. It's gonna work out in the end. Now we finished everything basically, and now here you can either hit the escape button to do this like I did, or for example another way to do it is after, for example, you have chosen this and you want to, like, you have put one component down, so you want to stop, and like you will put this down and now you want to stop, so you just press stop, and now you just have just this cursor that like shows you, if you see here, it shows you the coordinates where you are on your schematic basically. Now we're going to select this, group this, and we're going to delete it because we don't need it. Now, before there used to be a command in EAGLE, there used to be line and wire, and it was very confusing which one is which. So EAGLE finally on the version 8.5 decided to get rid of that, and now just uses the command called net. So with the net command, it's very easy right now. It like solves a lot of problems. So basically, we're going to get and connect all our components right now. This goes with this one, and then these go together. Now, if you let's get the pins completely. So from pin number 5, we're gonna connect to C number 2. From pin number 4, wait, let me make another line here because we need this for our power supply later. And now here you press the escape button, right? Just like usual. Now you click here, you make this bend, and you click on the line. Now, if you don't see this point here, which means a junction, that means that there's no connection in there. And if there's no connection in there, when you go and you do your board layout, you're not going to have this connection, and most likely your PCB will be useless at the end, because sometimes you have to wire everything, like things don't work like that. So you have to be careful. So whenever you don't see this, make sure to like go back and delete things and redo them. It doesn't take that long. Now we're gonna take from pin number 7, we're gonna go down here, make this junction here. Oh, sorry. And now from pin number 3, we're gonna go straight here. Just let me make something, move my camera. Then from pin number 6, we need to make a connection between the resistor here and the capacitor. Now we have left pin number 8, 1, and 2. Now pin number 2 is gonna connect here. Now if you notice, you're gonna say these two lines here cross, but it's exactly what I said you before. If you don't have this junction point, then there's no connection, so you are safe. Don't worry about crossing lines. I mean, all right, it's a bit tedious. I could have drawn this better, but it's whatever. I'm gonna fix it later on my board layout. It's a simple enough circuit so I can understand it. Now here is a voltage input and this is the ground. So now you're gonna say, where is the power supply? You're not connecting this to anything, right? So there's two ways to do this. So the first way is to grab a line from the positive and going to every positive where I want the power supply, which is here, here, and I need a power supply also here, right? And make 3 power supplies with wires. Or I can do something and take from the supply library, take a 9-volt supply and add it in here, and add it in here. And then I can take, instead of wiring the ground myself to these pieces, I can just add the ground just like I did. And it's the better way to do it that way. I say that because if you use the ground from the library, you're telling, because every one of these things means a signal. So if you tell the schematic that you have a ground signal, it makes it much easier later when you design your PCB, and it is, you're gonna see how helpful it is. So I would suggest keeping it that way. So to add a new part, also here, you see this part here, it has the add part button, has two parts in between, has this small arrow. If you click that, you have all the parts that you have added previously. So that's a good way to keep in mind if you like forget something. So now I need to get power supply, so I go to find a supply library. There should be two of them. So here, the supply symbol. So if we go at supply 2, we get the 9-volt supply, and we go here, and then we supply this. Yes, we want to do that, because we were telling what we did by that is that we told EAGLE that these 9 volts are the same signal. That's what we did. Now we said we needed another one here, and we needed another one here. Now we need to add our grounds. We hit the escape button, and then we go to supply 1 now. Just a simple GND, not too crazy. And then you go here, yes, and then you go here. Let's rotate this around, this one. Okay, so I press the stop. Okay, I forgot one ground, so I can use this. So right here is the one that I just used previously, GND from supply 1 library. This is helpful because sometimes components have the same name, so you have to check out from what library it comes from. So I add it here. So we should be done now with anything from adding parts, I believe. So now let's wrap up and connect these lines together. So we're gonna do this, and we're gonna connect a junction here, and then this connects here, this connects here, and this connects. I believe that we should be done. And also, for example, to grab, instead of like zooming in, zooming out all the time, you can zoom in and you can keep the mouse wheel clicked, and you can drag like this. Okay, perfect. Looks like everything is connected correctly. Now you're gonna tell me, what is the value of this R1 and R2 or this capacitor? What are the values of this? So the good thing with EAGLE is that, or let's say with the technology today, is that we are offered parts that like are of the same size and have the same, let's say, physical requirements in a PCB, but they offer different possibilities for you. So for example, with this structure of a resistor, we may have many different resistors basically of different values. So what we do to define the value is that we go here and we have on the left side, under the, after we finish with lines, you have name and you have value. Now we want value because they already have a name, but I'm going to show you also how to change the name just in case. So you take this and you basically just click on them. So for this R1, we are going to use 1 kilo ohm. You just write 1K. And then for R2, we're going to use 100K. For R3, we are going to use 300 ohms. And for this one, we're going to use 300 ohms. Any questions so far?
Yeah, about those 9-volt sources and the grounds that you put around the schematic, are those just like links to the power source we put in, or?
Yes, basically yes. But if you do it this way, you're telling the eagle, because a computer is basically dumb, like you're talking to it. So by doing this, you're telling it that there exists a signal 9 volts.
Okay.
And there exists a signal ground. So it's also an easier way for you, because you don't work with PCBs this small with this much components. And if you have to put this voltage everywhere and do wires, you're going to have a spider web that's like impossible to untangle. So that's why this refers to this. And if you remember, it popped up, it gave us a pop-up window here that said, is it the AB 9 volts signal? And I said, yes, it is that, because that's what I'm referring to.
Okay, thank you.
No problem. Now, we can go on and add the values for our capacitors, and the values for our capacitors will be this one, 10 nanofarads. They're quite small and negligible, but they're needed there. And this one should be 1 nanofarad. Yes. So, okay, so basically now the circuit is basically all done. Now, yeah, this is a schematic basically. It's so easy to do. And now we're gonna see what are some things that you want to do here, some tips and tricks for you in this case, or like some documentation that you can put, or like some advice basically. Sometimes we have, wait, this zoom thing. Maybe you want to group these things. For example, you have big printed circuit boards, they may have different power supplies. So, or for example, you want to group this part of the schematic, and you move that. If we choose this in the left top corner, we choose the group, and we select this, and we can group this. Where is it? Where is it? I lost it. New group. And we can name this LEDs. Right? And this, and I can move this wherever I want. And it keeps the connections like it should. It's not going to change everything. It's not going to change anything. And this is a good way for you to separate the circuit board, because just like with the programming script, you want to go back and to look at comments. This is a way to do it also for schematics. Like this is the best way to do it. So I'm going to go ahead and oops, I'm going to just undo. So I'm going to click this again, and I'm going to ungroup this. I don't want this. Where is it? Oh my God. So this is what happens usually. This is the usual stuff. So we ungroup this. So now let's just go ahead and save this, so we keep it saved. And now your Eagle, when it will install, you're going to choose a path file where it was going to keep all your projects. I have chosen it very simple. I keep it under my documents Eagle, and it has projects. The bold one is where you are at, PCB workshop, and I'm going to name it PCB, or I want to say Blink IEEE Blinko schematic. And if you see it, it saves it as a schematic itself, so there's no need. So we save this. This is saved now, so you're all good. We're gonna do zoom to fit. These are some good things. So this zoom to fit is the one I use mostly at the end to like check everything. What have I missed? And I see that I have missed something here. This frame offers you the opportunity to add details to your board basically. And now here it says title. If you notice, I saved the file IEEE Blinko schematic. So it does that thing, it does it automatically. But then here, it still gives you like a blank part here. So in that blank part, we can add some text if we want. So enter text here, and we're gonna say IEEE PCB, excuse me, shift enter to add a new line. And then here we're gonna do maybe, let's name it, just say Blinko board, keep it simple. Okay. Okay, now we see these drags here. Now I can click on this, but do you see this bar here that's giving you? What does this mean is that this is alignment, basically what it is, that's obvious, but this ratio is the boldness. So basically, I don't know if you can see, but basically the new one is bolder than this. I don't know if it's obvious. It's not that big, just a little bit. This one, I would say keep this one proportional always. What does this mean, proportional? Proportional means that if you ever decide to export this as a PDF, it is readable. So you can copy it and you can search it, and it's a useful tool basically to keep. So now I'm going to basically stop this thing, and I want to give you now some to give you an idea of how to use, for example, this flashing board somewhere in another circuit. So an easy way to do this is, if we click all of this, we can go to File, and it's gonna say Save as Design Block. So as I said before, design blocks are just basically big pieces that you use to that you save so you can use later for easier purpose, because you might want to build a bigger circuit, or you just have it ready and you just want to do a new one. So you save it and you press Save As and add design blocks, and I'm going to name it Blinko block. And it says DBL design block, and you can always use it later. And see now at the part, when you have here add part, you also have add a design block. So if I choose add a design block, I have this here, which is very simple, and I say okay, a new one, and it says paste from the file, and it has all the pins needed. And you're just gonna confirm. Right now I'm gonna say cancel because I already have it, and I don't want another one. But now some tips and tricks basically for this. If you see in this line here, you can write, this is the command line of, what the hell did I do? Okay, technical difficulties. Hey, let me check something real quick. Okay, so in this line here, we have the command line. Basically, it's very helpful. Right now that I've been using it for some time, it's a bit tedious for me to go every single time, hit add part, search, and do all those things. So I can just do add. And it's gonna pop up like this, and you use tab functions and the tab button to like go to places. For example, I'm at search, I press tab, go to the other one, right? Or for example, you want to move something, you press move, and now you're having this command, and now you can move things. And and the good thing about moving components is that if they're netted, it's gonna bring the line with them, so which is nice, and it's not gonna mess up your let's say your whole board for it. So other advice that I would probably give you for using this would be, use your cursor as much as you can, like move a whole lot. And when you use very big printed circuit board, when you design big printed circuit boards, you want to just see what where your resistors are basically. So what you want to do is that you go to the command line and you say show R. Right. Show R1. Did it make it brighter? What the heck? R2. Okay, so I'm going to do it this way. So now it's going to, this line, this pop-up window shows you the components that you have. And it's very helpful sometimes because you can use it R2 now. And see, it made this brighter red. Maybe if you use a different background, it's going to be more obvious. But if you see it popped up, which is nice because sometimes you want to find a component in a very big board, and it's so tedious, and you're never going to find it. So you can just use that. It's a small trick. And an advice that I would give: always use the command line. Makes your life easier. So with them a net, and you can net stuff. And if you press the exit button here, basically it just gives up what you did. Control Z, the stuff, that's the usual stuff. What did I have here? Well, this is it for the schematic. Now, basically, I want to show you guys how to create your own spice model using this. Because it's a bit of a tedious process. Yes, last night I tried my best to find the spice model file for this. It was impossible. So I'm going to show you how to model all the rest of them, basically. And I'm going to show you a part of a video where he does a simulation, basically. So if you select all this and you right click, and then you right click this and it says add model. So you want to press this add model here, and it says, do you want to convert all parts including GND in the name to spice ground node 0? Yes, because GND is ground node 0. And if you remember, I told you you should make a signal like this because it's gonna help you like a lot. And now it's going to give you all your components here. Now, if you see all these here, parts here that are on green are very common used parts. So it's just going to map it itself, or probably are libraries that already contain the spice model with them. But these ones are weird. Now, what do you notice here? It says LED1, and LED is not an inductor, first of all. An LED is a diode. So we're going to go here and we're going to see this one. And now it says map. Well, we're going to find a model. So we're going to find a model and we're going to say load model. Usually the models are, if you go at this PC and you need to find the files of the whole, find the files where the program is installed. And if you go to examples, it's going to tell you, where is it? Spice. It's a spice. So for LEDs, I would use D model file. And now I can press OK. And it tells me a model file. Do you want to overwrite it? Yes, I want to do. OK, perfect. Now it's going to tell which one are the inputs. And to do, I say yes, those are correct, whatever. And do the same with LED number 2 if you see the same problem. Okay, so we want to map, do the same thing again. It's a bit tedious, honestly, but sometimes, and I'm gonna say to you why not to use it all that much, because there's better software, honestly, for this. Because basically what Eagle does is, in this simulation part, is that it just uses LT Spice to do this. And why do you need to use Eagle to use LT Spice when you can just do LT Spice and use components that already have everything fixed up like it should be? And in this one, it's gonna, and I'm gonna map this as independent voltage source. So I'm gonna map it. Okay, perfect. Now for this one, this is our chip. This is our timer basically here. So I'm gonna try and map this, and I'm gonna do a sub circuit here, and I'm gonna do load model. And if I see at the desktop, this is the only file that it would map to honestly, but it doesn't work in simulation. So this is how SPICE models are. It basically is just, I don't know, to me right now looks like some senseless crap because I don't know what it means. Probably you can fix this. I think that you should add a star in front of everything to fix it, but I'm not 100% sure. But somehow it maps it. It maps everything, which is very surprising to me. So I say done, and then now you're going to simulate. But what are you going to simulate? Do you have an ammeter or a voltage probe here? No, you don't. So you come and add the ammeter, and you add the ammeter. You add it from a library called ngSpice. So let me find it really quickly. And ngSpice is a library that everything there contains already the SPICE model. Like we're sure for that library, maybe not for others, but for that we are. And that also has the voltage probes, has the ammeters and everything. So so it says ngSpice digital and ngSpice simulation. So we want simulation. So we just add an ammeter there. And we just add it here, and we add another one here, and we see the junctions we made there. Okay, perfect. And now if I go and simulate this, it says that it cannot be simulated, and it is because of this thing here. I tried yesterday my best, so I'm just going to show you a video. And now you use transient to do the thing, and you set the start time and stop time that you want, and that is it's a good tool, but it's like a tedious process. I wanted to show it to you guys that like it exists. Like if you search well enough, and if you are that far advanced that you can write your own SPICE models, sure, go for it. And like it's helpful, why not do it on the same software? But there are other software that probably are better in simulating circuits. But anyway, I'm gonna show you. Okay, so it's here. So if you see here, even the notations are a bit different. So now he pressed simulate up there. And then you basically, yeah, you just press simulate, it gives you everything that it needs itself, it fills itself. And yeah, this is a graph that it comes, and it is absolutely correct. Now what he does is that he wants to get rid of those two voltages because he doesn't want. So he goes at signals and checks the ones that he doesn't want off. So he presses apply changes, because if you do clear all, it's going to get rid of everything. Now this is still too messy for you to look at. So you can zoom at it by basically doing using either the wheel or by like just like you do with group, basically. Yes, after it stops, and you can see now how the circuit was. It's a good tool. So basically this was it for the simulation, and I believe that we are done with the part of the schematics. Now after you are done with the schematics, the next part is to go on and make, wait, there's a chat. I'm not sure, but I would say LT Spice, it's one of the oldest ones probably. So you need to check, because this is a microcontroller, basically like a small chip, a timer. But I would suggest looking into LT Spice or P Spice probably. I don't know if that helps. I'm not an expert by no means. Now if we're done, we check everything once again. We go here. I don't want this anymore, so I'm just going to delete them. So I'm just going to press Ctrl Z twice. Okay, so we are done here, and you can add all sorts of cool stuff here. Maybe add a text to say, I don't know, 1, 2, 3. May make it big and like, okay, whatever. Yeah, you can edit there. And yeah, you're done basically. And at that text, actually, even if you use the HTML syntax to do bold, it works like that too, actually. So if you guys know HTML and like it, you can do that. It works exactly the same basics. So let's go ahead and create our board, and let's see how this thing goes on. So it says the board doesn't exist, and you want to create this from a schematic. Yes, well, we want to create this from a schematic. So we're going to press yes, and now we see a lot of things in here. We see these things, all of them are selected, and all of these are the layers. Now it looks like a lot. This thing is a whole mesh in there. You have this manufacturing, Fusion 360, Fusion team, and then you have another set of, like, actually only this set here like kind of changes a little bit, but the rest is all the same, all the same. You have zoom to fit again, and then you have the key is a CAM processor, and here you can go back to your schematic board. And some people like to work like this. They like to put them like this. Come on, are you kidding me? Some people like to keep stuff like this. It's easier for you to like check what things are, but I mean it's a easy enough circuit for us not to do that for now. So okay, perfect. So we are here. I want to firstly say and point out for why is this related to Fusion 360. So we know the Fusion 360 is basically like a 3D modeling CAD, and actually it's a helpful tool. I personally don't like using it because I don't do all that fancy stuff with my printed circuit board, but it's easier. Like when you have a software that like you can cut this board and make arcs that you want to make, maybe I don't know, a heart or something. It's easier to do it with that. You can choose the width and you can design it. It's very simple. I personally don't need to use it. I use pretty conventional rectangular rectangular boards. So I mean everyone can do what they feel. But what I would say that is very important is this manufacturing, and this here is going to show you how your PCB looks. Until now, if you notice, I have not put any copper, no pads, no wires in my PCB at all. So I have literally nothing. It's just gonna be a film, a green film here, and you're done. That's it. Like there's nothing to it. Here you have the board. It gives you everything: pads, drills, routing. It gives you a lot of information. We're gonna see in the end how things are going to change. So right now everything is green. I'm gonna close this, and now I want to explain what this means. So now this is selected. I can select anything on this. Can select air wires. These are called air wires. This yellow thing is. I can select the frame. I can select the pads. I can select the name. But if I select the name, see, it's so difficult. Like I can't move things. Like it's just so. I just created another line, so it's pointless. So what you do is that you go back and you look here and you want just a device. And when you do the device is going to grab everything that it has with it. So and you see that it has like a cross in the middle, and you click there, left click, and now Let me show you. If you see down here at this bar here, this is so helpful. This shows you and gives you instructions how to move these things, because it gets so frustrating sometimes because you click things and you don't know what they are and it gets annoying. So just look there, and that's your next step basically. So now we go, let me close this down. So okay, I'm gonna go here and I'm gonna drag this. Now actually this is perfect for me because I want this no, actually no, I want this plus and minus to come away from this way. That's how I want to do my circuit board this time. I want to keep them inside the board. Now I'm gonna go and grab my LED number 2. So my LED number 2 is gonna be here probably, and I want to rotate it. I'm gonna keep it like this. I'm gonna grab my LED number 1 and I'm gonna drag it, and I rotate it by right clicking, and I just let my left part of the mouse off, and it's just gonna go there and click into place. Now what I want to do is that I want to grab this component, and this component is my timer. So I'm gonna grab my timer and I'm gonna rotate it like this. I'm gonna put it somewhere here probably. And now if you notice, this is how your component is supposed to look like. And if you see these gray markings, these are part of the silk screen. And when you produce when you manufacture the printed circuit board, these gray stuff, they will be printed on your board, but there will not be copper there. It's just basically a way for you to, like, you know where to put your component when you want to install it afterwards. Now I want to grab my capacitors. Now for this one, come on. It doesn't want to. Okay, it did it. So now I'm going to rotate it like this once probably, and put it here maybe. I'm going to keep it here. Or here. Keep it here, whatever. And I'm going to get these ones, do the same thing. I'm going to rotate them. And I'm going to keep them. I'm going to put them here for now actually. And see, you see like how stuff moves around. So I'm going to group this. Okay, so I'm just gonna make some place for these ones here. Okay, perfect. So now I'm gonna select everything and get this a bit higher probably. Just give myself some space. I don't have to make such a tight printed circuit board. Make this a little bit more symmetric. Here, it looks better already. And just get this one tightly here. And now, if you notice, these things are not aligned here. Like they have like spaces different from one another, and when you want to solder it afterwards, you're gonna have a bit of trouble, because if you have something close, and these are also like surface mounted pads, so it's like they're tedious already. So why do you want to make it tedious for yourself? So if you grab all these and if you click here, you have this align one. So what you want to do first is that you align left edges, and then on the end of this toolbar, you have something called distribute vertically. And you press that, and what it does is that it removes the y coordinate, finds the difference from y coordinate from here to here, and separates it by the number of spaces that it needs, and basically just moves them at the coordinates it has, removes this cross here to the coordinates that it has calculated basically. And you can do the same thing for everything, honestly. Like you can line up, align. It's a helpful tool. And here I'm gonna decide to like maybe come on, no, I'm at the line right now, so I'm sorry for that. So if I want to move this a bit further, I'm going to move them right now. So now for this one, I don't want these LEDs to be here. I think that my board is too long right now. What about I remove these names from up here and put this one at the top and this one at the bottom. So for that one, we can use something, a tool here in the left toolbar called reposition attribute. So if we select that one, and if we go here, oh, I'm sorry, and if you select that one, and you see this one, then it gives you positions at top left, top middle, top right. I want it to be bottom middle. So I'm gonna click it here, and it's gonna remove it itself in there. Now for this upper one, I want it at top middle. So I'm gonna click here, and it's gonna move it itself. Now I can make it a bit shorter. Okay, now looks good, but I'm sorry. Okay, now if you go to manufacturing, you're gonna see how it looks, right? A lot of things changed. You can see the copper wires on it, so it's gonna print these white things. This is just gonna be seal screen. This is just naming convention, basically. That's gonna show you where things go. And this, where you see this yellow thing, there's no soldering mask there. So basically you can solder there. Wherever you have green, there basically is a soldering mask. So that means that you cannot touch the copper. Now we're gonna go and see how can we do these traces, because we see that we have the components right now. We have the through holes for the component, but we don't have anything for how do these connect with each other, or like how they're going to work out. So now we're going to use the tools here. We choose the first one. It's called the root air wire. Now at the toolbar up top, you have the width. This is 6. It is conventional considering the DRC, the regulations that are down here. You can change this, but it's giving the one that you probably need. And then these are very important. Now it says ignore obstacles. This is the only thing that I would suggest don't use, because you're going full maniac, and I'm going to show you like why it is full maniac. You have walk around obstacles and you have push obstacles. I like using the walk around obstacles because it's easier. So basically you click at the pad where you start, and then boom, you made the connection. You select the other pad and boom, you made the other connection. Now let me select this ignore obstacles. Now it says plus 9 volt here, right? Do you see the signal? Now if I do this is going to connect here, but if you notice this red lined part here, that's EAGLE that's telling you in real time that this is going to cause you thermal issues. Or basically, this is going to mean you're going to do a short circuit here somehow. So probably it's not the best idea to use that. So what you do is that you want to use this walk around obstacles. So if you see, it does it for you, and there's no need to go all crazy. It's a good tool. So just use it. Don't make experiments and then have a PCB that doesn't work, because you're going to be sad because it takes a lot of time. So here we notice that the LED1 and LED2, this one is wired, the two pads. But maybe I don't like this wiring. So what I do is that I want to delete it. And how to delete it is that you press this button called rip up. And when you do rip up, you have trace, connected copper on same layer, because sometimes something is very important is this is a PCB with 2 layers, probably it's going to be with 2 layers. But sometimes you have with many layers, and you don't want to delete something from a layer that already is good. So you want to be, for example, from the same layer. And now you go here, and if you see it's not clicking anything. And why is it not clicking anything? The reason is because here the selection filter, I have selected only devices, and the wire is not a device. So what I do is that I reset that, and now I can delete it. And if you see, it's giving me air wires now. Now I deleted those whole 3 lines. So what I want to do right now is show you guys, before doing any other traces, show you guys how to do the grounding here, because you here don't see any like power supply going through or anything. The power supply is going from here, right? As I said, that plus 9 volt is going, it's making the wires here, and this negative is going here. But this has to be grounded. No, this has to be grounded. I'm sorry, this is the minus. This has to be grounded. But where is that ground going? Because it needs to be grounded, basically. So now what we do is we use a tool called polygon. And let me actually first sizen up this because it's too big. We don't want it to be too big. So basically what you do is that you get this, you grab the frame, both sides, and good enough. Okay, perfect. So now there are 2 ways to fix the grounding issue in this problem. So we can grab the tool polygon, and the tool polygon is here in this toolbar, and you can trace around basically. And this is, don't worry about this, it's just like this, it's just doing a line all over. Okay, and now this is done. And I'm gonna name this for the signal name GND, and it's gonna relate to that GND. And now if I press OK, oh, excuse me. Oh, okay, perfect. So now, if I do, what do I need to do to show this? If I do, you see these wires here right now? Now, we have the ground, we have these wires, there's a lot of things going on. So I need to like fix them, find a better way for them to go around. So I press the function called the rat's nest. The rat's nest is gonna find the shortest routes possible, and it's gonna show you what connections are already made. So as noticed, it shortened a lot of things, firstly, as we noticed from these wires. And secondly, as we see, there's like this huge red thing, which is a problem, and you cannot see anything. But what do you see here? Do you see this big red X? That means that there's a thermal connection there. Here you see that there is no thermal connection there. So what this is saying is that from the negative pole of the battery, it's going and it's connecting where it should be, right? It's making a whole sheet that's going to be ground for you, right here, ground here, and ground, and ground. Like it's telling you what signals are, and it's very nice. So that's why things relate right now, why we use supply and why we use GND. So it's a helpful tool. Now, but we don't want it because we haven't finished yet. So what we do is that we go to this rip up, and we have this tool. Don't press this. This is you deleting every signal, so that you're killing your work. So don't do that. So you're gonna press all visible polygons, and you're gonna end up like you were in the beginning, and which is better. And if you notice now, we don't have the lines of the ground, air wires of the ground going anymore because they're wired. So that's perfect. So now we can go on and wire the rest of the things. Now we can do this manually, but I want to show to you guys how you can do this. Or let me actually show you something else before. I want to show you what vias are, or vias. You say, okay. Now I want to route from here. So if you see, I'm probably gonna have to cross these two lines here. So I'm just gonna make this connection here for now, and I'll figure out how to change this one. So I will start with this. And here is said, let me click this, ignore. So if you press ignore, you can see that there's a thermal connection that the DRC does not allow. So what you want to do is that if you press the space bar, you're going to have a via. And the via, what basically is a copper connection between two layers. And that copper connection between two layers is so useful because it's going to take you to another layer where these two lines do not meet up anymore with each other. So now if I press left click, you're going to see here that the layer is blue right now. That means that it's the bottom layer. So I can go freely here and not worry too much about it. Oh, I'm sorry, that was a mistake because it did not connect. So now you press the space again because you want to go to the first layer again because the resistor is in the first layer. So you left click and now you see that the wire is red again. So now you connect it. So as we see, we were first layer, go underneath this wire by going to the bottom layer, go to the first layer via copper connection, which is made with a drill, go back to the SMD that was on top. So that's a very important thing to know. But usually we want to avoid vias. It's not the more holes you have in your PCB, the worse it is. Right, the cost is going to be bigger, and like it's going to cost more. It's going to take longer to manufacture and everything. But it doesn't matter all that much with this type. So now we're going to use something called an auto router. If this was like EAGLE 7 point something, I would say don't do it because you're gonna have something that's not correct. But right now in the 9.5 edition that I have, I don't know which one it is right now, it's probably higher with the updates. It makes your life so much easier. And you just press auto router and basically you have here, it says effort low. You can choose medium or high. I mean, there's no need to do high. You can just do medium. And the higher this is, I mean, the longer it's gonna take, the higher the effort is. So I'm just gonna press continue and it's gonna give me like opportunities. And I can evaluate each one of them. And this one, I'm gonna evaluate this. I'm gonna say start this. And I'm gonna say, hey, okay, it did it. I'm gonna press evaluate right now. So let me remove the polygon again, and we remove the polygon by doing red's nest and going press red's nest, and then we go to repop all visible polygons. And actually, an advice here that you could probably use after you do that, so like what happened now won't happen again, you probably can just do set poly off, right? And now you're fine. You don't need to like go and do those things ever again. So now, I mean, I like this job. Like it's all right. It's not the end of the world. So it makes these connections, whatever. Now I'm gonna go ahead and see how this thing looks in my manufacturing board. So if you see here, we have these traces. Everything is traced down right now. The polygon is here. It looks good enough. So we can just do some cleaning ups now, which we can do the last cleaning ups. Maybe this one doesn't look as clean, but it's fine. The more time you spend with it, the better it looks, but it's whatever. Now, what I want to show you is that when it gets printed, these edges are very sharp, and you want to avoid them as you can, because sometimes in different companies choose to edge them themselves or no, and some other ones just don't do anything for them. But the ones that edge them themselves usually may cut things that you want. So it's not the best idea to just assume. So you'd rather do it yourself and just be happy with your own work. So you choose the tool meter. The meter one has two possibilities. It has a straight one, which makes a 45-degree angle cut in corners, and you have something which is a round one, and you want to use a round one. And you select to the corner, and you pull it. You go to each corner and you do the same thing. Here, for example, this one is too big, so I'm gonna pull it here. Okay, I'm gonna make everything even. Kill me. Okay. Yeah, it looks good enough. And now usually, because you're supposed to like put this somewhere, you usually even want to put two holes. I like putting mine here in the edge. And wait, I want to use a bigger one, so I'm going to use the biggest one that they have. So I'm going to use this one here and this one here. And we're going to see how that impacts the manufacturing process. So if you see, you have these edges cut here, you have these two, you have the other one. Maybe you want to add a hole here. So yeah, so you go to manufacturing and you see that there's a hole there now. Maybe we don't want that one, but just saying that you can do this stuff. Okay, now you can try maybe to make sure about everything. You can use a dimensions tool about your board layouts. And what does a dimension tool help you with? So the dimension tools helps you with is like seems like measuring how big things are. So right now we're at the board layout, like we have snapped everything, like now it doesn't hurt. So like if you want to keep this in like millimeters or something, yeah, there's no issue with it, honestly. So now you just go, so you can like find out a better one, and you find the other angle, the other side, good enough, and then you go here and you have it like this. But this, what I just made right now, is a mistake. And why is it a mistake? The mistake is that I made this calculation in the top layer, and it's gonna show when I print it out, and I don't want that. So how can I do that? So now comes the idea of using these layers, and we see we have a lot of them. This B restrict, for example, is a solder mask. There you can find it's very easy. This for the names, for the values, for the dimensions. So maybe we can just use measures. And whatever is like gray like this usually doesn't print, depends on what it is. I'm going to use measures. I want to do it in there, and I'm going to choose from here. Let me click again. I'm not there. So as you see now, it's not red anymore, because the red was the top layer. Now it's like gray. And we can see that this is one measurement, And this is what you expect in real life. And we choose the other one. I'm sorry. Don't choose that one. Okay. I need to fix this. Wait, where did the measures? Oh, here. Okay, whatever. Okay, so let's do this once. I'm sorry, it's taking a while. Okay, yeah. And this one is selected. Nope. Ah, come on. Now basically just like catches the same thing, which is annoying. But let me see if I can do this. Oh, oh, wow, stupid. So now that it was horizontal, so now you choose the vertical one. I was like, why is it not working? Okay, that makes much more sense. Okay, so now you have everything. And when you get your printed circuit board back, you have these measurements, you can change them. And now we're gonna take a 10-minute break, and guys can go drink some water or something, and we're gonna come back. We have time actually. We're gonna come back. We're gonna see how to process these things. Maybe like figure out if I have any more advice for the circuit boards. Generate the burger files. I'm going to show you where, for example, give you some examples of where and how to print this, some companies maybe, and we are going to go and do this component, make our own component with this. Does it sound all right? I'm going to be stopping share for now. Okay. So I guess we are starting again at 12:50. Does it sound good? Okay, perfect. Okay, perfect. Okay, so I'm gonna share screen again. Go to Eagle. Okay, so should I go ahead? Okay, good. Okay, so here we have the printed circuit board that we make. This is the board layout. This is how everything is going to look. Now there's two ways to do this. So we can either go ahead and do it from the toolbar up here, or we can do it from a manufacturing point down here. So one way, let's try this one. Is called, okay, I need to say this. This is okay. So let's save. Now this is a CAM processor, and this is going to generate CAM data. So now we need to do CAM processor, and we can start from here. And it's very simple. It's like even it can zip it for you if you want. I would suggest doing exporting it as zip. Sometimes it's worth it, but it depends on where are you submitting the file. Or you can do generate CAM data, and it's just gonna do it immediately, right? That's another way. Or the long way, and probably I would say the best way, so you make sure that everything is correct. You go here and you see, oh, is everything like I want it to be? And I see, oh, this angle here is wrong, so I need to fix this, and I need to add the holes that probably were removed. So let's finish that. So if I go here and I take the meter again, and wait, it's not allowing me. Okay, this is all done and good. Now we can add those two holes that we said, and we do the holes for this, and we're going to use the drill. And it's going to be top layer. Do this and this, and now we should be all good. We stop this, and now we see manufacturing, and we see everything is good. And as noted, these measurements here, they're not there anymore, right? Because they were just in the measurements layer, and the measurements layer doesn't have anything to do with you manufacturing it, because it already has all the coordinates and the assembly directions. So now after you have seen this, you see the board and you see what properties it had. You can see very different things. You see the area bounding the box, width, height. You see all these things, and it's extremely helpful because these are what tell you what the cost is going to be. You have how many components you need, how on the top layers, how many SMDs, how many through holes, how many pads, how many drills you have. These are very important things to take care of, because if you think about it, and if you're like producing something in a very large scale, and for example you're putting a printed circuit board in a car, you have to check the stresses, you have to check the thermal heats and everything, and all these components, these through hole, the way they're put, the way the stress is distributed in this board, everything is very important. So the more complicated your job is, the more things you have to look at. And these are the drills that are used. And now you go to the preview and you press CAM, and says your design has changed. Save your design, yes. And then we go at the same place. Now you have bill of materials, you have basically everything here. So now after you have finished, so these are called the Gerber files, and they contain everything: top copper, bottom copper, profile, solder mask. They have a lot of different things, which is very helpful. And these are what create the assembly files down here and how everything is put together. So we press process job right now, and we see at the PCB workshop, we can say IEEE Blinko and say manufacturing, probably. I don't know. It does not exist. Okay, it wants a folder, so we're gonna choose this. So folder is Blinky board. Wait, show details. No, cancel. Wait, let me find out which one it is. Okay, now if you open folder, now we can see that we have the CAM outputs here. Right, everything is here, the assembly line, the drill files, the Gerber files, and everything. Now, what are some ways for us to actually get this? We are all done at Eagle right now. Like, hey, we don't have anything more to do. This was the last step. So how do we deal with this right now? Like, how do we go and manufacture this? There, it's so simple actually to go and print the circuit board. So you just do print, you just search, and I have used before PCB way actually, so I'm just gonna go there. So if you say there and you do PCB quote or something, and it says standard PCB. Okay, so if you see these things right now, these are very very important stuff. So we have 2 layers, we have 1 different design. It's a single piece, we don't want the whole lot. We're gonna use the lowest, most common level. Thickness, usually go 1.6. And these are, depending on what you're doing, this is the spacing of your conductors, and you want to make sure. This is a solder mask, and we want it green. You can make it yellow, whatever. You can make it whatever you want. The silk screen is the name, so we're gonna keep it white. Gold fingers, no. Surface finish, we're gonna use with lead, and then vias, tenting vias. And then finished copper is going to be 1 ounce copper. This 1 ounce copper basically means the thickness of it. You can search this online. It's very easy to find the differences between those two. And now you go and what's the other one? Calculate, I guess. It was millimeters. It was 700, I think. 718 with 200. I'm gonna put 5 blinkies. 5 blinkies. Now, if I do calculate, and it's gonna say if you want it for 24 hours, it's gonna give you that price. Now, whatever. We're just going to go to the next one. Why is it not letting me? Okay, we're just going to use a Gerber online. Gerber file reader. So yeah, if you do online Gerber viewer. Let me try this. Okay, this is a mess. Excuse me for this. Actually, I don't know which one I use. Fire online. Let me do it really quickly. Sorry. I'm so sorry for this. Okay, it's right here. So yeah, now, so if I upload it, zip files work too. So now if I choose this and I go here at my Blinky board, at the Blinky board, or not the Blinky board, the PCB workshop. We choose this and we choose the Gerber file. We press open and now we select all of them. Now we see that this is how it looks. Right, layers, this is how it looks, this is how the bottom looks, this is how the top looks, and this is a way for you to check if everything is correct. And now you can choose what to see and what not to see, but you can see that all the connections are made and it's good, and this is down to production. And depending on where you want to buy these things, and like where you want to print these things, on the price and the thing, there are many different opportunities. I've used a PCBWay before. Usually to find the ones that are in China usually helps better because they're usually cheaper, but the shipping costs a bit more. But yeah, that's generally it. Now let's quickly jump and let's make this component ourselves. So how do we do that? So let me close this. So let me close this. Now we can create now a new, at the projects, I can say new project, and I call it timer basically. Now at the timer, I want to add a new library. A new library is going to help us create a new component. And basically how it works out is that you start with a package and then, or a footprint, you go start with a footprint, you do the symbol, you mix them up together, and you create a so-called device, which is in the end. So you start with making the footprint in the beginning. So I'm going to name it timer, create new footprint timer, yes. And now here we see that we have a whole black pitch, and you can change the description of these things. I can just say here, any 555 N, because I'm going to use through holes. I'm going to do OK here. And now how to do it? Is it usually like the best? I mean, right now I'm just going to eyeball it, but usually what you want to do is you want to open the technical details file for the component, and usually it is very easy to find those online, and you see what the parameters are, and you can make it that way. But we are not going to do that right now. So we're just going to take a line and we're gonna start here, and we're gonna make this shape, and this is gonna be the footprint. Okay, so this is the first part. Now we can do the second part, and we want to use this type of pads, maybe long like this, well, maybe offset. Maybe offset is better. So we're gonna add 1, 2, 3, and 4 of them. And I'm gonna mirror this and go 1, 2, 3, and 4. Now I want to, when you design a component, basically to tell the person that like where these pins start and like what's their order, you usually make an arc here at the top, just to let people know that it starts from this side. And I'm gonna change the names of these pins, and I'm gonna say pin 1, pin 2, 3, 4. Now you start from upside down now. 5 and 6 and 7 and 8. Wait, why did the arc thing go? Wait. Okay, So we have the pins here. This is the footprint, and basically what the footprint does is that it's going to put this gray line in the silk screen, and it's going to put these things will be the pads basically. This is where the copper will be. These are where you mount your component basically. Now that was with through holes. Maybe you want to add an SMD. For SMDs, you can add them like this. So maybe 1, 2, 3, and 4. SMDs are usually more compact than through holes because, and it's probably a better choice. But if you see here, see how much space this is taking, see how much space this is taking. So depends on what the component is. But if it's like a custom component, you want it to have less space, which is a good thing. So now after we do that, we save it. After we saved it, we go to project timer and we say timer 1 or timer 555. After we save that, and now we open this and we say symbol, add the symbol, and we say timer, create new symbol for timer. Now what we want to do is that again, we get the line, or no, let's start by just putting the pins. So you start by putting the pins, and pins are here, and you start by putting 8 different pins, and you're saying 1, 2, 3, 4, you mirror it, and you say here 5, 6, 7, 8. Perfect. And now you take your line and you're going to connect these things just like you did with that, and you get the arc, and right there, that's the symbol for your for your component. And basically what you want to do is that your component is not named like this. It has a sort of convention, and basically I'm going to use right now and find out what the component is. I've written it down, and I'm going to change the names to how they should be. So the first pin, I'm going to go and take the name tag here, and I'm going to go, you click at the pin because that's where the center is, and this one is going to be ground, so I say GND. The second one is going to be control voltage. So the third one is going to be resistors. The fourth one is going to be this. The fifth one is, and so on. We keep doing this. And the last one should be input voltage. Now this is done. That was it basically. And now we have the footprint, which is going to be what goes on the board layout, and this is what stays on the schematic. So that's how EAGLE works. You put this on a schematic somewhere, and EAGLE takes the footprint of that component and puts it on the board layout for you. That's why these two files should be held up together in a device. And now we say device, new device name, and a new device name. I'm just going to call it and timer 555. Create new device timer 555. Okay, perfect. And now I'm going to do, wait, I need to add local package. Okay, we added the local package and new. Now we add from, wait, pin pad. Oh, we need to add the other one right now. Where is my timer? Wait, did I save the symbol? Yeah, wait, I'll save it here. Now, if we go to device, okay. Now, let me find out where this is. Yeah. This is very confusing right now. Device. Okay. This is added. I'll press next. Okay. Cancel. How do you add this? Forgot. Attribute. Wait. Well, I'm so sorry. I haven't seen the chat actually. Wait. Let me see the chat. Okay. How do you normally go about ordering all the components for your PCB? So how I would do it is basically, yeah, probably you're right, Marshall, about the size. There's a lot of going on right now. But how I would go about ordering all the components for my PCBs is that I would do this. So I would go Texas Instruments basically, and you would search, for example, any 555 timer there, and you have here the data sheet. And then here, because usually Texas Instruments produces everything, and here you have the actual picture of how it looks, and then you have the data sheet, what are all the technical documentation, and then if you go underneath here, and you have the price of them. So you add this to the cart, and then you keep on with everything. I don't know, does that help? Let me know in the chat. Oh, in the chat. Okay. So all good? Okay, I'm going back here. So hey, this is so confusing. Open. Oh, see. Where is there should be something here. Okay. Okay. Let me try something. Zoom recording. Okay. So once again, we edit the part using this command. So we add the symbol through this, and then now we have in this side, we edit our footprint through add a local package, and we selected this and we press OK, and we have it here. It is already defined, so I'm not going to do a new one. Now this one has its pins from 1 to 8. And this one has pins with different names. So now we need to make sure that these things match with each other. So now we're going to connect them, and we need to be very careful. So now we need to find 1 and ground, and we press connect. So pin 1 and pad 1 and pin ground are connected together. Now the second one should be pin 2 and CV. So it's going to be pin 2 and CV and connect. And we're going to keep doing this, 3 and R, 4 and T, R, yes, 5 and Q, okay, perfect, 6 and this, 7 and this one, and 8 with the voltage, okay, perfect. And now we simply press OK, and now it's done. And now we save this, and this library should be easy connected. Yes. Okay, perfect. And it is connected. Now we need to use this, right? So how are we going to use it? Let's close it down. So let's go, and for example, let's go at the PCB workshop that we had. So let's go at the schematic. And when we open this and we want to add that to our library, so we open library manager and we say available, and we say browse. So we need to find out where did we create that. So at projects, we should have it under timer. It is this one. So we open this and wait, did it open? Wait, T is before W. Yes, it's right there, right? So now we're going to use it. Perfect. So so now we can go here and we can say add part now. And if we do add part, we can search out for timer here, and timer should be here. And if we see a timer, we should have the component right here, and the component is okay here, and it has everything in there. It has a number of the pin with their name specific to it. And this is a very, very good tool, because sometimes you want to make custom things. You want to make probably a component for Arduino that you probably want to mount on a PCB, and that's usually how it goes. So that should be me. That should be what I had for today. If you guys have any questions, please feel free to ask, and I'll try to go over it again. So I'm going once, twice, and okay, I'm going to give the word to Matt to talk about the future events of what we have in IEEE. So do you want to take it on from here, Matt?
Yeah, sure. Can you pull up the slide with the?
Yes, I can do that.
All right, awesome, cool, thanks. All right, so hey everybody. First of all, thank you very much for coming. So my name is Matt Rance. I'm the president for Drexel IEEE for the upcoming year, and yeah, I just want to talk to you guys a little bit about what the rest of our events for summer look like. So coming up this week on the 6th at 7 is a student networking panel. And so basically what that's going to be is we've invited some students to be on the panel that have done things like BSMS, STAR, co-ops out of the state, research, and other things. Just to one, kind of talk about their experiences with all of those. But also, and this is kind of the main point of it, just to provide like a time and space for like you to like interact with other students as well as people that have had these experiences before, so you can learn a little bit about them, see if any of the experiences they've gone through interest you, hear about what pieces of advice they might have, etc. And so yeah, after that we have like in conjunction with the ECE department, ECE Quizzo, which will be during the week 8 ECE chat. That'll be a lot of fun because it'll be students teaming up with faculty to answer a bunch of Quizzo style questions. So yeah, that should be a lot of fun. And if you've ever wanted more of a chance to kind of interact directly with some ECE faculty and get to know them, this is a great way to do that. And then finally, we're doing a virtual Dragon Hacks from Home August 14th through 16th. So for those of you guys that might not have heard of Dragon Hacks before, it's usually our biggest event of the year. It's a usually 24-hour hackathon. Basically, you come, you work on a project for a set amount of time, and it gets judged by some of the companies that come and sponsor, and you can win some cool prizes. So while we're still doing we're still going to do like the actual like bigger Dragon Hacks, whether it be virtual or in person if it's safe. next year, be it in the winter or spring term. We figured that for summer term, we do kind of like a smaller scale virtual Dragon hacks. So what'll be different about this than the normal one is that it'll be Drexel students only. You'll have 36 hours to work on a project, and there won't be like a first, second, or third place when it comes to prizes. The categories are going to be judged by the companies that are sponsoring. So, like for example, Google is one of the companies that'll be at this virtual Dragon Hacks from Home. And I think like they're doing a couple categories, and one of them is best use of GCP, their cloud platform. And so yeah, even if you've never done a hackathon before, they'll still be doing things like tech talks and like different little workshops throughout the event. So even if you just wanted to listen to those, you can definitely do that. We'll have some like more like solid information about sign up and things like that coming out within the next couple of days. But yeah, those are just some things to keep an eye out if you're interested in any of them. The links for all of those will be in our link tree at some point or another, which I will copy and paste and put in the chat. Highly recommend bookmarking it because that's where we'll put things like our Zoom links and all of that. And yeah, so if you want to stay connected with us, if you haven't done so already, make sure you join us on Dragon Link. You'll get emails from us about events like this, the PCB workshop, as well as other opportunities that we might have coming up. Also, join the Slack because that's where a lot of our communication is. And if you ever want to reach out to somebody within IEEE, that's usually kind of the best and quickest avenue to do so. And yeah, also all of our socials are on there as well. YouTube, which is where we'll be uploading this if you want to go back to reference for it. And other things like Instagram and LinkedIn and Facebook. So yeah, once again, thank you guys all very, very much for coming. Thank you to Ray also. I thought you did really well with this PCB workshop. And yeah.
Okay, so that's perfect to wrap it up. This was the first time when we did the PCB workshop, so we would really, really appreciate if you could give us feedback on it, what we could make better, and like